Alright, this is the notes for section 8.3. If you haven't done so already, take a quick read of the section first before going on. Pretty much this section is about going through the activity as it pertains to finding the area of an irregular figure. So we're going to just kind of walk through this activity together here. So if I look at step 1, it says, so we have Christmas Island and we've superimposed it on a graph, okay? And each one of these squares is 8 miles on a side. So if it's 8 miles on a side, we know that the area of one of those squares is 64 square miles. Okay? So the first thing that we're going to do is we're going to count up the squares that are completely covered by the island. Now we have this one highlighted on here. It's this purple one. So that there's only one square that's completely covered by the island. Okay? We call that the number of inside squares. When a square is completely covered by the figure that we're trying to measure, we count it as an inside square. Okay? The second type of squares that we're going to be counting are boundary squares. Now boundary squares, when we count boundary squares, what we're going to do is we're going to count any square that is partially the island. It might be partially island and partially water, but if it is, we're counting it. So I'm going to try and do this in an orderly way. Okay, so I'm just going to go up and down, okay, and count all of the ones that have at least some part of it covered by the island. And I think I have them all there, and then we're going to count those up, which gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of boundary squares that we have, part B, is 11. Okay? Now, it doesn't matter that some of them are really full and some of them are not very full, but we're just going to kind of average that out. So basically, we're going to count each one of those boundary squares as being like a half a square. So we're going to take 1/2 times the number of boundary squares. So if I take the one square that I have plus half the boundary squares, well, we said we had 11 boundary squares. Well, half of that would be 5.5. And if I take that total times the area of one of these squares, well, if each square is 8 miles by 8 miles, we say that we're going to call that value U. U represents the area of one of those squares. Well, that's going to be 8 miles squared, which is equal to 64 square miles. So I'm going to take this value times 64, and if I do that, if I multiply that out, I get 416 square miles. So that would represent the area of our estimate from this graph up here. Okay, this is wrong here. It should be 416 square miles. Now in step 2, we're going to do the exact same thing, but this time now, when we do it, we're going to do it on a new grid. And in this grid, instead of it being each one of the squares being 8 miles with a length and width of 8 miles, now it has a length and a width of 4 miles. Okay, so we're going to have more squares, but our estimate should be pretty close to what we had before. So what I'd like you to do right now is just pause the video and go ahead and count up your inside squares, your boundary squares, so your I value and your B value, and then I'd also like you to calculate a value for U, the area of one of those squares. So in step 2 now, what I've done is I've counted up the inside squares, the boundary squares, and I calculated a value for U. So I found that I had 6 inside squares. Those would be the ones that are in the red X's. I found that there were a total of 26 boundary squares, the ones that are the black little marks there. And then I also found that the value of U, since each square is 4 units on a side, or 4 miles on a side, the area for one of those squares would be 16 square miles. So now I'm going to take my formula for the area. Area is equal to the inside squares plus half the boundary squares times u. And I'm going to plug in those values. If I do that, I'm left with 19 times 16, which is 304 square miles. Now you'll notice that, the difference between the number I got in step 1 and step 2 is somewhat substantial. But the better estimate here is the second estimate, because the smaller the square, the more accurate I can be with my estimate. Okay, so this is definitely a better estimate. Now if I look at step 3, it says below each square has a side of 2 miles. So its area is 4 square miles. So now my u value here is going to be 4 square miles. So what we want to do is we want to do the same thing for that one. So if you can go through and cut up your boundary squares and your inside squares, and we'll get a calculation for a area based on this new grid. So if you look at if you count up your inside squares on this one, you should come up with about 48. If you look at your boundary squares, I came up with something close to 48. Now, as the squares get smaller, our error on that can be a little bit, in terms of determining whether a square is actually an inside square or not, is a little bit questionable, especially as your grids are a little bit smaller. But I came up with 48. You might have a number that's somewhat close to that, but not exactly the same. So if I go ahead and plug that stuff in, 48 plus half of 48 times 4, that gives me 72 times 4, or 288 square miles. So there's certainly, on a question like this, there would be a range of values that would be acceptable, but 288 square miles is a very good estimate for what we have. Now you'll notice that the estimate kind of got smaller each time. That isn't necessarily the case, but what will happen is that your estimate will become much more accurate the smaller our grid becomes.